let's dive into a underutilized utility for debugging production systems called strace. The first place that I really got into the weeds with strace was when I was working at Weta Digital in New Zealand, and we had this very interesting problem where when you launched Python, it would take about 60 seconds to execute a script, and it was really a big problem because the film industry has lots of different Python scripts that were running all over the place. Finally, what we figured out was that it was talking to the file system thousands and thousands of times, and that was actually what was causing the issue. Once we were able to get to the root cause of that, everything was able to be dramatically sped up because we had wrapper scripts that would intercept that lookup call to the network, and the file server had much better performance. The scripts had much better performance. And the only way we were able to really get into the weeds with this was to use strace to look at the different parameters of what the script was doing. So it's an amazing tool that if you need to dive into the weeds on a problem and get into what's happening at a network level, a system level, etc., a file system level, it is a tool for you. So let's go ahead and talk about the foundations of the strace utility. So from an origin standpoint, this thing has been a trace tool that was iterated on. It was a Linux, Unix diagnostic utility. So a lot of tools have been like that, right? They keep improving over time. And the core functionality is that it intercepts and records calls executed by processes and signals. And from a architectural implementation, it's going to leverage the kernel as well. So this is the origins of it. Now, in terms of the technical implementation parameters for the modern version, the underlying mechanism is that it's going to attach to a running process, a PID, via the ptrace system call. So this is really the magic of strace, is that it works very well for production systems. Let's say that you had something that is really critical that takes hours to run, let's say a big data job or a machine learning or generative AI training job. Potentially strace could be the only tool that could help you out, because you can talk to the running process and not kill it, but maybe get in there and figure out what's happening. In terms of the operational modalities, we have the process execution monitoring. This is -F. So you can look at the child processes as well. So sometimes the parent is hiding what the children are doing, and deep inside of some child process, there's something very wrong happening. And so if you do -F, this will follow that fork and it'll look inside of that child process. We can also look at time measurement. So -T, for example, will give you that. We can look at statistical analysis as well. So if you do -C, this would look at syscall frequency duration. So statistical analysis can be very, very helpful. Like, hey, how many times is this being called? Like, what is the root cause of this? And sometimes you'll find very surprising behavior that you just were not aware of. And just one little change can make a huge difference to the performance of your system in production. In terms of the output, it's going to give you back the syscall, args, and return value. And then in terms of the interface granularity, we've got some small differences between 64-bit and 32-bit via the ABI handlers. Now, in terms of advanced usage, some of the things to be aware of with the strace ecosystem, you can do microsecond precision timing. You can filter protocols, so you can selectively look at things via pattern matching /regex. You can do file descriptor tracking, so you can look at comprehensive I/O operation monitoring. So you can look at what's happening at a file system level. You can look at signal interception as well. You can look at IPC mechanisms, so shared memory segments, semaphores, message queues. In terms of the methodological limitations here, we also can look at things like execution degradation from context switching, temporal resolution. So we can look at microsecond precision, non-deterministic things as well, like race conditions or scheduling anomalies. And this is where following the forks can really pay dividends. You can also look at behavioral modifications like Heisenberg type observer effect. Like if you're observing it, like what happens? Is it changing the behavior itself? And then in terms of a comparative analysis of different tools, where does it fit in? Well, we have also ltrace, which is library call tracing. We have ft trace or kernel function tracing. We have performance counters or perf. And also it's complementary to GDB because it's a different abstraction level, right? So GDB is going to help you at the code level. This is going to help you at really the implementation level. And then in terms of the security implications, you do need privileged access. So that is one thing to be aware of. Like, for example, in an environment where you don't have privileged access, this is not going to be an option. So really, if we wrap things up here, it's good for root cause analysis. Like, for example, trying to find the pattern that is at the root of the problem. Also, it's good for security auditing. Can you see if there's privilege escalation and resource access, binary analysis? We can look at the black box of some binary, maybe that's running on your system. This is a great way to dig into it. And this is why they disable it on some proprietary OSs, like on Apple OS, right? They disable Strace because they don't want you to know what it's doing. We also have containerization diagnostics, so you can actually look inside and see what's happening. So really useful tool, Strace. And if you're stuck with a running system where you need it to keep running and you're scared that if you kill it, it will take hours and hours and hours to get back to where you were, Strace might be the only tool that you can use to help you get to the root cause. You can find out that there's some sub-process or some component that's stuck, and you can, basically free it up so that the main process can continue to run. So I've personally used Strace quite a bit to solve really tricky problems, and I still use Strace today to solve tricky problems, and it's worth taking a look at, and it's also something we cover in courses at Pragmatic AI Labs.